Hello everyone. Today I'm going to explain polling in computer networks. So what is polling? Polling is a technique used in computer networking that helps devices take turns while sharing data on a network. It's kind of like passing a talking stick. The person with the talking stick gets to speak, right? Similarly, the person who gets selected during a poll will have the chance to send or receive data. Now, polling comes under the controlled access protocol method. So to understand polling better, we'll first see what is controlled access. So what is controlled access? In computer networks, sometimes multiple devices want to send data at the same time. But if they all talk at once, their messages can never get reached. It may be scrambled or talked over, so we won't get to know the right message. So to avoid these data collisions, we used controlled access. And controlled access is a way to avoid that mess. It makes sure only one node gets to send data at a time. And it's just like a traffic signal managing cars at an intersection. So where is it used? Controlled access protocol methods like polling are used in the data link layer of the networks. We know that a physical layer is used to transfer a data physically, like a physical connection is being set up and the physical addressing is done. But what about the orderly and smooth delivery of data? Data link layer comes into picture, and in that we have controlled access protocol techniques like polling, which takes care of data collisions, etc. Now, there are three methods of controlled access, namely reservation, polling, and token passing. And today we'll focus on polling, which is super useful for networks that need clear, structured communication. So moving on, we'll see polling in detail. In polling, one device is the boss, and all the other devices are considered as secondary devices and they follow the boss lead. The primary device first checks with each secondary devices and asks them if they have any data to send. And this checking process is called poll function. So now for an illustration purpose, think of polling like a teacher. A teacher asking each student in the class if they have a question, and then if each student, a secondary device, has something to say, they respond. If not, the teacher will just move on to the next student or the next topic. And this keeps the things organized and avoids talking over each other in the class. Similarly, polling does the same in the concept of networking. So let's break down the poll function a little bit more. If the primary device wants to receive the data, then it asks each secondary device, that is, it puts a poll and asks each secondary device, do you have anything to send? And if the answer is yes, then the particular device shares the data and an acknowledgement is received. Else, if it doesn't have any data to send, a negative acknowledgement is sent to the primary device saying that it doesn't have any data to send. And this way, the polling keeps the communication channel clear and avoids data collision. Now, what if the primary device wants to send data? In that case, it uses what's called the select function. The primary device tells the secondary device in advance to get ready to receive the data that it has to send. Now, before sending the data, the primary device uses a select poll. That is, a select frame is created and sent to all the secondary devices, and whichever device wants that particular information sends an acknowledgement saying that it needs the frame. And then the information is sent to that particular secondary device and an acknowledgement is received. Now, to understand the select function, imagine a boss giving a heads up to his employees before sharing any important information. It works just like that. So here is a visual representation of how polling and select function works. So here this black PC is considered the primary node and all the other PCs are secondary devices. So in this case, the poll function is being sent. The polling is happening. First, the primary device sends a poll to the first PC and it says it doesn't have any data to send, so a negative acknowledgement is sent. So next, the primary device moves on and sends the poll and asks the next device if it has any data to send. Since this device has a data to send, it sends the data and an acknowledgement is received. Similarly, in the select function, the primary device selects one of the secondary device and asks if it needs the data. If the particular secondary device needs the data, it sends an acknowledgement saying it needs the data. Then the data is forwarded and an acknowledgement is received. Now, so why use polling? First, it's predictable and we know the order in which each device can share the data. So this makes the data transfer smooth and reliable. Also, it lets us prioritize certain devices if needed, giving them faster access. But polling has its downsides too. Mainly, the main drawback is that it relies heavily on the primary device or the primary controller. So if the primary device has any problem, then the whole network could be affected. Also, polling can slow down things when there is a very little data to send. Imagine you have to stand in a queue to get something when there is barely anyone around. So that is another drawback of polling. To overcome these drawbacks, we have other two methods like reservation or or we can use token passing. Finally, to conclude, in short, polling helps networks stay organized and avoid communication chaos. So if you want to avoid data collisions, you must make sure that you implement a controlled access protocol, which in this case is polling. It's not perfect, but it's a great solution to keep the data flowing in an orderly way. Thanks for watching, and I hope you enjoyed learning about polling. Thank you.